Okay, here's an example of a volume problem that was made by the people who make your AP tests. You need to pay really close attention to any questions that they make up because they keep making up the same basic questions year after year. And if you can train yourself to answer those questions, you should pass your exam. If you have a copy of this, which if you're in my class you should, this is the third one on the practice test. Okay, so this is a typical volume problem, and I call volume problems the ones where you're going to have to do shells or discs or washers or cross sections. Usually you'll find the area as well. On the BC exam, you may or may not get this as one of your 6. There's a pretty good chance you will. On the AB test, there's an even better chance that you will. But if you don't, it will definitely show up in the multiple choice, all of these skills. So this is a graph of e to the 2x from 0 to 1, and we're going to answer some questions about it. First of all, tangent line. The probably best way to make a tangent line is like you did in Algebra 1, where if you know a point and a slope, y minus y1 equals the slope times x minus x1. If they do not ask you for a specific form, get any form of that equation and move on. All right, you don't have to put it into mx plus b form. And in calculus, we're going to use calc to find this slope, and therefore the point slope form is usually the best way to go. So let's work on finding the point and the slope. Well, I know the point, it's 1 comma e squared. That point is showing right here. And I'm going to find the tangent line to the graph at that point. So I just need to know the slope. And as it says at the top, this is a non-calculator question. So I need to find the slope of e to the 2x at x equals 1. So let's start by taking the derivative of f of x, which would be 2e to the 2x. All right, chain rule applies. The derivative of e to the u is e to the u du. That's where that 2 comes from. So f prime of 1 is 2e squared. So what do you need to find a line, a point, and a slope? So my point is 1 comma e squared. My slope is 2e squared. So my final answer is y minus y1. y1 is the y coordinate of the point that I do know. Y minus e squared equals slope 2e squared times x minus x1, x minus 1. All right, so on the answer key that I have, they moved that e squared to the other side, and they wrote it y equals e squared plus 2e squared times x minus 1. But like I said, if they don't specify, you're more than welcome to get it in the form that you want and move along to the next part. All right, so the next part, and this, I like this, by the way, because it looks like your test is going to look. All right, you see these 3's, you see all the space. A lot of the released questions that we answer are all packed in to fit on one page, but this is the paper you're going to be writing on. All right, so find the area of R, part B. I'm going to answer part B up here where I have some space, so I don't have to keep scrolling. The area of R. Now, area is just an integral process, all right? The integral of the equation gives us the area. So I'll need to integrate from 0 to 1, e to the 2x dx. Nothing fancy about this one. A lot of times on these problems you will get an area part, which is just an integral. Sometimes it's top function minus bottom function. Sometimes there's only one function, like in this case. So if you recall, we're going to do an e to the u integral. This is a very common mistake. Once you get past this, you don't do them every day. When you're working on the E chapter, when you go back to them, it's easy to confuse. This 2 that we did down here a minute ago, f prime, that 2 right there, with the 1/2 that we're going to get over here. All right, I need there to be a 2 inside this integral in order for me to integrate. I need there to be a 1/2 on the outside. All right, so my integral is 1/2 times e to the 2x from 1 to 0, from 0 to 1. All right, that making that 1/2 a 2 or forgetting it altogether are by far the most common mistakes. So if I sub in my 1, I get 1/2 e squared. If I sub in my 0, I get 1/2 e to the 0, which is just 1/2. A little bit nicer version might be factor that 1/2 out and get e squared minus 1. All right, nothing too difficult so far. If you can remember the difference between chain rule and U substitution, which are just opposites of each other, then you're in great shape. All right, third part says region R forms the base of a solid whose cross sections perpendicular to the y-axis are squares. Write but do not evaluate an expression involving one or more integrals that gives the volume. So this is one of these cross-sectional area volumes. Again, I'm going to solve it up here where I have some space. I know that my cross sections perpendicular to the y-axis are squares. So down here at the bottoms, if you could try to visualize, down at the bottom, those squares would be kind of like that, because it's a wider section of the graph. Somewhere up here in the middle, a little square would look like that, and you'd be moving to a point up there. Sometimes these are hard to see, but what you need to remember is that you need to integrate the area. And this one was perpendicular to the y-axis, so we're going to integrate the area dy. And since everything needs to be a y, including the limits of integration, I'm going to go from 0 to e squared. Now here's the issue with this one. It gave you a hint. It said use one or more integrals. The problem is these squares down here are constantly 1 by 1 squares. All of those. These, once I get above 1, they start to depend on the function. So I need to break this into 2 integrals. But again, it kind of told me, gave me a hint. And this bottom one doesn't even really need to be an integral. It's going to be a 1 by 1 by 1 cube, because all of those squares are have a side length of 1. So that 1 right there takes care of all the volume in red down at the bottom. Adding on to that, I'm going to go from 1 to e squared, because this level right here at y equals 1 is where I change over. And now I need to integrate the area of a square. You remember from many years ago, the area of a square is the side length squared. So if I can come up with an expression for the side length of each one of these little rectangles, right? How long is this green line? Then I'll be done. I can sub that in for side length, and that'll be it. All right? So this is going to be a subtraction problem. If I want to find the length of that green line, from here all the way over is 1, and from here to here has a couple of possible names. That little distance right there from the y-axis over to the graph is x. However, I'm not just going to call it x. I'm going to call it whatever x equals in terms of y. All right, so since my function is y equals e to the 2x, if I solve this for x, I'm going to natural log both sides. Natural log of y equals 2x. And I'm going to divide by 2 or multiply by 1/2. So 1/2 natural log of y equals x. So this green line would be the quantity 1 minus x, but instead of calling it x, I need to call it 1/2 natural log of y squared dy. So don't forget that 1 that you had from the cube at the bottom, and then that integral from 1 to e squared is going to give us the rest of it. And so like I said, this was written by the people that are going to write your tests. If you look through old years, you're going to see a lot of the same questions. The thing that wasn't on this question that is on a lot of them is the discs / washers / shells, usually washers. All right, but just to review quickly, we had a tangent line, which isn't always a part of the volume question, but it's definitely a topic you need to understand. We had area up here, just integrating the function, no biggie. And then we have volume of a known cross-section over here. 3 good, solid questions that you are likely to see. So make sure you can do that, get a little bit closer to that college credit. Young out.